let's go over some fun facts about thermistors. Being a semiconductor, the exact nonlinear curve for temperature versus resistance is highly material dependent. You will see this in the formulation of the nonlinear equations. Most thermistors in use are NTC, which stands for negative temperature coefficient. Their resistance decreases drastically as temperature increases. The base resistance of a thermistor is its resistance at 25 degrees Celsius. The most common base resistances are 2,252 ohms and 10,000 ohms. These are used in the narrowband applications for smartphones and computers, essentially between minus 50 degrees C and plus 70 degrees C. With good calibration, you can get thermistor accuracies of 0.1 degrees C to 0.2 degrees C. Thermistors are packaged in glass or epoxy, which limits their upper temperature range. You can measure up to 200 degrees Celsius with a thermistor, but you need to use higher base resistances such as 30,000 ohms or 50,000 ohms to get the accuracy you need. Thermistors have a wide usage in applications where small package size and narrow temperature range intersect. They're commonly used for overheating protection in smartphones, PCs, and laptops. The contrast of LCDs naturally fades at the upper end of the temperature range, and a thermistor measures the internal temperature of an LCD and is used to compensate the contrast signal for this effect. Once upon a time, thermostats used bimetallic strips as their temperature elements, but these days, thermostats use thermistors too. My favorite application for thermistors is to integrate them into lithium batteries. And with all the worries about lithium batteries overheating on airplanes, internal temperature measurement within a battery has become standard. So standard that you can buy lithium batteries with a pre-installed thermistor on eBay. This one goes for $11.90. Thermistors are packaged in mechanical and electronic forms. You can buy them in the form of an IC like the MPC 9700. You can buy them packaged in a metal probe, similar to how you would buy a thermocouple. The 10K ohm probe is designed for a fluid immersion application. And the 4400 8RC thermistor is a through-hole part ready for assembly to a board. Let's recap. We discussed the accuracy, the range, and typical applications for thermistors. Now let's review the core technology and calibration equations that govern thermistors, as well as how to integrate them into embedded systems.